Hi, everyone, and welcome to today's webinar, Improving Healthcare Delivery Through Systems Engineering, presented by Zane Scott. My name is Donna Long, and I will be your host during today's webinar. As Vice President of Professional Services at Vitech, Zane Scott manages the company's consulting and training organization. For the past 25 years, Zane has built a skill set that enables him to provide insight and guidance to individuals and companies as they improve organizational processes and methodologies. Zane has also taught systems engineering methodology in a variety of settings, is a frequent blogger, and is co-author of Vitech's book, A Primer for Model-Based Systems Engineering. Before joining Vitech, Zane worked as a senior consultant and process analyst assisting government and industry clients in implementing and managing organizational change. Before Zane gets started, I have just a few housekeeping items. We will be answering questions at the end of the webinar. Please send your questions in as soon as you think of them through the question tab on the webinar control panel. Zane will answer as many of these questions as he can today, but if we do not get to your question, we will reach out to you after the webinar. The webinar is being recorded. If you experience connection problems during the live presentation, a recording will be made available within 1 business day. The recording will be published to Vitech's webinar archive, located on our website. At the conclusion of this webinar, a survey will open on your screen. Please take a moment to give us feedback on today's presentation or on what topics you'd like to see covered in future webinars. Now I'm going to turn the presentation over to Zane. Welcome.
Good morning, everybody. As Donna said, we're going to talk about healthcare delivery and systems engineering today. I have really a twofold purpose in doing this and in talking about healthcare delivery in particular. The overarching purpose is to talk about how systems engineering might go about expanding its footprint, particularly in the non-traditional areas. We have a tendency to expand by looking at how we might be of service at the application level. But I'd like to move to the conceptual level and to talk about how we might expand into areas where we have not traditionally been players and where we might help at the same time. So the area of healthcare delivery is a good way to go about discussing this in practical terms. Number one, it's not traditional. It's not part of our military aerospace usual market space. It's not product centric, it's service centric. And so on that basis, I chose it as an area to discuss and illustrate how we might expand our footprint. The other reason for choosing it is it's an area that I'm interested in and doing some work in, and is of particular interest to me, and I think probably to a number of you as well. So all of that makes it a worthy area for consideration in and of itself. Recently at the NCOSE IW, we had a discussion forum to talk about healthcare delivery, and much of the ideas that you'll see today have been influenced by the discussion among the participants in that forum. We had a good, lively discussion. We made a decision to have a follow-on group and continue that conversation. And for any of you who are NCOSE members and are interested, you are welcome to join that group. And all you need to do to become a part of it would be to email me with your interests, and I'll forward that on to the facilitator. We are very, very fortunate to have Kendra Kreutz as the facilitator for that group, and Kendra is moving the conversation forward and doing good things with it. So I think it's an area that if you're interested in this particular subject, where you may well want to participate. When we look at areas where we might expand our footprint, we need to detect a need and an opportunity for us to move into a particular area. Where could we be of service, and where do we have the ability to impact it? In looking at the need in the area of healthcare delivery as a case in point, I was reminded of the often used illustration that the Chinese symbol for crisis combines the symbol for danger, which you see on the left-hand side, and a symbol that is often said to be a symbol for opportunity. It's really not directly a symbol for opportunity. It's actually the symbol for the point at which change must occur, or an inflection point. So danger and an inflection point where change is occurring or will occur is the formula for crisis in the Chinese language. Very often we hear that we have a healthcare crisis, and when we talk about the healthcare crisis, we're typically talking about healthcare delivery. So that's led me into my inquiry into the area of healthcare delivery, and a particular effort to look at how systems engineering might play in that space. If you look at NCOSE's Vision 2025, A World in Motion, what you see is that the vision recognizes that there's an imperative that we have to expand systems engineering's footprint. So we need to look at how we might move into other domains. NCOSE talks about two things. One is that there's a need to solve problems, that we have numbers of problems that can be solved through the design of increasingly complex systems or the improvement of existing complex systems. And systems engineering has a lot to offer in those sorts of situations. So we can meet important needs, and systems engineering is relevant because we're positioned to help with the complex systems that create those needs and that are used to solve those needs. So the first question, if we're going to move into a non-traditional space, is it an opportunity? Is it really an opportunity for systems engineering? Is there room for systems engineering is the threshold question. In other words, is this a commercially viable area that would justify us making the business decision to move into it? And when we look at commercial viability, I think in the healthcare sector, we can do this by comparing it to our usual space. So we know that systems engineering is viable in the defense spending space, because we've been there. We work there pretty regularly. We have lots of experience with that. And that's a rather large space. It's the defense spending in 2015 was $598 billion. That was 54% of the discretionary spending component of the budget of the United States. That's a larger expenditure than the total of spending by the next 14 largest national defense budgets. So it's a pretty substantial space, and it certainly has nurtured and supported the discipline of systems engineering. Well, if we know we're okay in the defense space at that size, how does that give us information about whether or not we would be okay in the healthcare delivery space? Well, we look at the defense expenditures at $598 billion, or 3.5% of the gross domestic product of the United States, and compare that to healthcare expenditures, which come in at $3.3 trillion and at 17.9% of the gross domestic product. So obviously we have a space that's big enough for us to have commercially viable opportunities. But that's not where our inquiry ends. The next thing that we need to know is need to know, are there problems that we can solve? And that's an expression of the two factors. On the one hand, needs, and on the other hand, relevance. So are there needs, are there problems, and are there problems that we can solve? In other words, is systems engineering relevant to the space? So does the space have needs, and does it have needs that can be addressed? In looking at the healthcare delivery space, the first area that we look at as potential for answering that is the area of waste and inefficiency. Systems engineering and systems design, particularly systems process design, can be directed at waste and inefficiency. So is that present? Well, Dartmouth Institute for Health Policy and Clinical Practice published a study that estimated, and this is really much in consonance with other estimates of the size of the waste, and that was that 30% of all Medicare clinical care spending could be avoided without worsening health outcomes. In other words, we could stop expending about 30% of all the Medicare clinical care spending and not worsen the health outcomes. We could still get the quality outcome that we're getting for 30% less in terms of dollars. And that involves eliminating waste. In fact, according to the Congressional Budget Office, the elimination of waste represents about $700 billion in savings when extrapolated to the total U.S. healthcare spending. So we can see that there is a problem with efficiency and waste. So that's one area where systems engineering could certainly be relevant in identifying and designing and improving delivery systems so as to eliminate that kind of waste. The other major area where we might identify problems that are relevant for solution through systems engineering methods and concepts is the area of health outcomes and the quality of those outcomes. When we look at that, what we find is that there's opportunity here as well. If you look at the number of deaths every year by cause in the United States, there's the Johns Hopkins study, which is most often cited for this, talks about the medical mistake as a cause of death being the third leading cause of death each year. So every year we have about 614,000 deaths from heart disease, 591,000 from cancer, and 251,000 from medical mistake. And then that's followed by lung disease and accident and stroke. So medical mistakes, in other words, a lowered quality, an unsatisfactory quality of healthcare delivery, turn out to be responsible for the third largest groups of death each year in the United States. Secondly, we have 45,000 annual deaths that are associated with a lack of health insurance, which is a problem of access to healthcare. So if we made the kinds of savings that we were talking about in terms of waste and inefficiency, those resources could be applied to increasing the access to healthcare in the population, which would result in better healthcare and a higher quality result there, and also reduce the the fatality outcomes in that particular area. So there is opportunity in terms of the quality that's being delivered and the accessibility of the outcomes that we like to see from healthcare delivery. So what are the keys to becoming involved in this area? How do we move into the area? What makes for a smooth and successful transition there? Very often this is like moving into a foreign country, moving into an environment where we have not been. We're very comfortable in the mil-aero and product spaces. We have language and jargon, and we have a familiarity. We know how the world works in that area, and so that's our comfort zone. But what about when we go outside the comfort zone? What do we need as our passport to working outside? Well, the first thing we need is that we need to respect the domain as we enter it. It's true in the area of healthcare delivery, and it's also true in other areas where we might work. If we look very carefully at the domain, one of the things that jumps out immediately is there are already systems engineers there and working. Now, most of them would not identify as systems engineers by name. So they're doing systems engineering, but they don't recognize themselves as systems engineers. And they don't realize that what they are doing is what we would describe as systems engineering. So that work is already going on. People have chosen approaches to doing that work. Folks who are working in the healthcare delivery domain and in the process design domain have selected approaches that work. One of the questions that we asked and discussed in our IW group was, what approach are you using? How did you come to use that approach? We focused on what folks are already doing. And we need to respect that work. Those folks have domain knowledge that we probably don't have, and we can learn much, but we need to be careful as we transition into any new domain to be sure that we're respectful. There's a Zen koan that says the greatest obstacle to learning is knowing. So if we head into a domain with the idea that we are the experts and we're here to rescue you, we're going to have a difficult time from a sociological standpoint, from a practical standpoint, from an organizational standpoint, and we're going to reduce the quality that we can expect to achieve because we're not respecting what's already there and what's already happening. The second key is that as we move into the area, we have to translate. We can't go in with a kind of colonial spirit that says, I'm here to impose my constructs, my ways of thinking, my language on you. If you want to practice systems engineering, you need to speak this language in this way. We need to learn to look at the concepts and to speak the language that describes the concepts that are applicable, that describe systems engineering concepts and that describe the domain specific concepts, so that we have a way of talking with the folks that we encounter as we move into that area. The third thing we need to learn to do is we need to learn to reflect our work and our insights that we bring in ways that are understandable to the folks who are already there. So if the folks who are there are used to flow charts as a way of understanding process flow, then we have ways of expressing that in the systems engineering world that can be understandable to them. And so we need to remember to reflect our work and insights, and we need to be very careful to do that in ways that are really understandable. And we check that understanding by learning to iterate. That means that as we look at systems, as we look at problems, as we look at solutions, we need to iterate our understanding to the folks that we're working with, to the point that they say, yes, that's it. You understand. You've got it. That's what I'm saying. And that's a matter of going through it with them and letting them say, well, that's almost it. But really, if I were going to describe it, I would say this. The thread that you see running through respect and translate and reflect and iterate is a thread of listening. I do some teaching of communications concepts in several different settings. And the single most important communication skill, and it's one that people don't expect, that they come to a communications course and we start off learning listening and they say, wait a minute, I came to learn how to do public speaking or writing or talking or facilitating or developing arguments, but you want to talk about listening. And that's because listening is the single most important communication skill. It's foundational to respect. It's foundational to being able to translate. It's foundational to being able to reflect in a way that's understandable. And it's foundational to the process of iteration, because as we iterate, what we want to do is listen to what our audience has to say as we make each iteration and act in the next iteration on the basis of what we've heard. So we're going to look fairly quickly at 3 different examples drawn from the healthcare industry, from the process design industry, and illustrating some of the points of the pillars that we just talked about. I'll say up front that these are 3 of many possible approaches. This doesn't cover the waterfront in healthcare, and it certainly doesn't cover the waterfront in all of the non-traditional domains where systems engineering is going on by some other name and by folks who wouldn't identify it as systems engineering. So these are just 3 of many possible approaches in the healthcare arena. I chose them because systems engineering in one form or another is already present in these approaches. The concepts are here, and so what I want to talk about as we talk about each one of these examples is I want to talk about how we might make the translation into what we understand as systems engineering and how we might deliver what we have to offer in an understandable way. The first example is the Safety Systems Engineering Intervention for Patient Safety, or SEEPS process. This is a process that is used in looking at healthcare processes and the delivery of outcomes. So in this, the SEEPS structure says that the structure of the environment in which you provide the processes, the structure of the organization, for instance, will determine what processes you're able to construct, and the processes that you construct control your outcomes. So you get your outcomes from your processes, and your processes grow out of your structure. Well, when we translate that to the arena of model-based systems engineering, for example, we see that when we look at systems models, that we have architecture, we have behavior or functionality or logical constructs, and we have the physical architecture that often we just simply refer to as architecture. The requirements are the outcomes that we expect and need from the system that's being designed or improved. The behavior correlates to what's called the processes. What do we do? And the architecture is a correlate of the structure. So we build the architecture in order to perform the behaviors that satisfy the requirements. Just as in the SEEPS analysis, you build the structures that enable your processes that produce your outcomes. So you can see if you're moving into an environment that is using the SEEPS constructs to look at their processes, you can make a pretty clear translation so that you can talk in both domains, so that you can talk in terms of the systems engineering language that we think in, and talk in terms of the SEEP constructs that are being used in the domain into what you're moving. So that's one example of a pretty clear translation. A second example has to do with design structure matrices. I encountered this in a very good paper, and if you're an NCOSE member, and you may think that I'm advertising NCOSE membership, and I am, but if you're an NCOSE member, you have access to the Systems Engineering Journal, and in volume 19, issue 3 in May of 2016, there was a paper called Process Modeling in the Operating Room. And in that paper, the authors, Bonzo, McLean, and Avnet, looked at the socio-technical processes of what is called the perioperative procedure. So, or process. So you can think of the perioperative process basically as beginning with asking the patient, have you had anything to eat or drink since midnight, etc. Beginning to prep the patient. It goes through prepping the patient, prepping the operating suite, getting everything together, moving the patient in, performing the procedure, and then the end of it is the patient being rolled out to move on to the next stage, which would be recovery or discharge, depending upon what process they're going through. So what they did in this paper, and what they did from a practical standpoint, was the problem that they identified was the necessity of quality communication. Quality communication among the steps of the process as they are undertaken and completed, and the communication among the personnel who carry this out. And what they did was construct a design structure matrix. Now, I can confess to you that when I first encountered this, I had to go away and learn what a design structure matrix was, learn how they operated, and then come back with that new understanding, for me at least, and see what they had done. So what they did was they took, in the excerpt that I've got up there that you can read, was they took the personnel, and where there was a connection between the two, so like communication from the OR tech back to the circulating registered nurse, they put a tick mark in that box above the diagonal. For systems engineers, they basically set up an N-squared chart with all of the personnel laid out on the diagonal. And then they looked at communication from the line to the column, so from the OR tech to the circulating RN, put a tick mark everywhere that needed to take place. And then they put tick marks where the line talked up to the column. In other words, for example, from the circulating RN to the OR tech. and they were able to track the communication among the staff. They did the same thing with the process steps. So where do the process steps need to have communication between the steps? They did that in a separate matrix, and then they put the two together in what is called a multi-domain matrix and looked at where the communication needed to take place between the personnel and the process steps. Put all that together and gathered a pretty clear picture of the communication structure that they had set out to study. It was a great way to gather that information. It was a great way to put it together and to maintain rigor and completeness and consistency, put it all together. But then they said something that I thought was really insightful. In the middle of their paper, they say, but this is not the most intuitive way to use to discuss what we're learning and what we're gathering with the folks who are actually involved in this. So if you took a multi-domain matrix to a hospital administrator, first thing you have to do is teach them what the matrix means and essentially put them through the process that I went through to understand the matrix. So in their paper, what they did was, from the information that they gathered about the matrix, they constructed what they called a network diagram. And that was what attracted my attention. Once I learned what the matrices were and saw that they had used that to come up with a network diagram, which looked to me like an activity diagram or an enhanced functional flow block diagram, I realized that I could take the information that they had gathered into their matrices, plug that information into a model-based systems engineering model where the elements are held in relationship to one another, catalog all of the elements and all of the relationships, put those together, and then I was able to use the MBSE tool that I used, which happened to be Vitex Genesis tool, to come up with an expression of the matrix information that was very understandable. In fact, I basically came up with something that looked pretty much like their network diagram in the form of an EFFBD. I was also able to generate other views, so I could generate the structure of the perioperative process. I could generate n-squared diagrams, which essentially were the same as the matrices that I was able to generate. I was able to look at sequence diagrams. So by ingesting that information that had been gathered in that very disciplined, rigorous, complete way, I was able to construct a model and then offer back different alternative ways of viewing what I had in the database and to look at what they wanted to look at and to posit solutions to the kinds of problems that they had set out to study. So there was a translation way, but a translation to be made rather, but the way in which that needed to be done was to give a good deal of consideration to how they had approached the problem and how they had approached coming up with a solution and building on that, and then offering the things that systems engineering could bring to the table there. And again, if you're interested in that paper, it's in Systems Engineering Magazine in volume 19, issue 3, which is the May 2016 issue of the magazine. Fascinating reading and a good illustration of this principle. The third example is the example of Lean Six Sigma. Very often in the healthcare delivery process world, you'll find folks who are out there using Lean Six Sigma concepts. They are improving the processes, looking for the waste steps, asking themselves what's critical to quality. Now, one of the things that's very interesting here is that most often when you are applying this, you are looking at what we in systems engineering would call a middle out problem. It's typically not greenfield development. You can't expect to go to a hospital administrator and say, hey, look, I can set up a perioperative process for you, which will be great. So what we need to do is I need for you to shut down your operating rooms for X amount of time while I do a process design. What you really do from a practical standpoint is you go in there and you look at the existing process and you begin to create first a picture of that process, and then ask yourself what steps exist that can't be traced to the critical to quality kinds of requirements, and look at what's the impact of the removal of steps on the process. You can use the Lean Six Sigma techniques, but you can strengthen it by creating a systems engineering model of those processes as you look at them. Why? Because when you set those up, when you begin to use, for example, a traceability hierarchy, when you look at the traceability hierarchy, you instantly see what steps are not traceable back to the requirements. You can look at a process and you can say, based on what you're doing, I think your requirements are this, 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 and this. They may have designed the process based on what they knew, but never gone through a requirements process at all. So when you say, here's what it looks like you want to get out of this process, and they say, oh no, I don't want that particular thing out of it. That's not a requirement for me. Then you can say, well, you're doing this step that satisfies that requirement. So now you have to ask yourself why. That's the same kind of process that you go through with Lean Six Sigma. So there you have 3 examples of how we might respect an existing approach, how we might go in and translate from one approach to the systems engineering realm, how we might reflect our understandings back to the folks who are already working in that domain, and how we would iterate and what we would show them as we iterate until they say, yes, that's it, that's accurate. These examples are pretty high level, and I've simplified them so that we don't get tangled up in the details. I recognize that to begin with, because the point that I want to make is that these are 3 separate approaches in this particular domain that we might encounter and that we might be able to work with and that we could leverage by using the concepts, methods, and tools of systems engineering. So, if we summarize, where have we been? What have we done? Well, we looked at this, and the first thing that we said is we looked at the opportunity. We said there's a looming healthcare crisis. We've got an aging population and increasing costs, and they're magnifying the pressures on the healthcare providers who have to design, maintain, and execute these healthcare delivery processes. So there's a big enough problem there. There's commercial viability for it because the expenditures are over 5 times the US DoD expenditures, and that's the environment that systems engineering has been surviving and thriving in for basically its whole history. So if there's opportunity with defense spending, there's certainly opportunity with healthcare. So it's a viable opportunity. There's ample room for us to offer improvement in terms of the healthcare outcomes. We're dealing with sub-quality outcomes that are the third leading cause of death in the United States every year. We're also dealing with deaths that come from the lack of access to the health care. So systems engineering can help both improve the quality of the outcomes and can improve the system that makes that accessible to more people than have it at this particular point. We know that there's waste there, so we know that systems engineering can address efficiency problems, and there's a significant opportunity to make a savings. And if you make that savings, then you have a pool of resources. We're better stewards of our resources, and we have more resources available to bring quality outcomes to a greater segment of the population. So there's an opportunity here. There is an opportunity in terms of need, and there's an opportunity in terms of relevance. The keys for moving into any new domains, including this one, are, as we've seen, respect, translation, reflection, and iteration. And we talked about those. By following those four principles, we promote the dialogue and cooperation with the systems engineers who already work in the area of healthcare process design and improvement, but don't call themselves systems engineering, probably don't recognize the principles, concepts, and methods that they use as being a form of systems engineering. And we also use those principles to avoid the temptation to go in a colonial way and simply supplant the existing efforts that are going on there. So systems engineering has a lot to offer in new domains, including this one. And those benefits can be categorized as integration, insight, and expression. As we looked at the four pillars, we saw that what we were offering there was an integrated ability to look at the system, typically through models. We gain insight as we look at it because we're able to share the information that we have with a broader audience in an understandable way, and we give new and different ways for the learnings that we find to be expressed to stakeholders, to process improvement and development specialists, to the audience in the new domains. So all of these contribute to better outcomes and better stewardship of the resources. I appreciate your time and your attention in this, and now I would be open to questions.
Thank you, Zane. We do have a few questions, thanks to all our participants. I encourage you to join the discussion now and submit your questions using your webinar control panel. Question from Josh. When you look at expanding systems engineering beyond the traditional spaces, what do you look for?
Well, as we talked about, what we're looking for first and foremost is there an opportunity that's viable in terms of commercial viability and work that we can get a hold of? So that's what leads us to ask, is there a need? Is it a big enough need to be able to support our work there? And is the need relevant to the kinds of problems and solutions that we can bring to the table.
Okay. The next question is from David. How do you learn to translate?
The first principle of translation is that you need to learn to listen to folks in the domain, and you need to learn the research/study skills to learn about the domain. So usually my process begins with asking somebody within the domain about their work and about the domain. People are absolutely thrilled to talk about what they do and the area that they work in. And when you can get folks to talk about that, then you can build up a chain of references from there. So somebody tells you, you ought to look at this. For instance, my example of the SEEPS process comes from discussions with Kendra Kreutz, who's facilitating the INCOSE conversation. Kendra introduced me to SEEPS and introduced me to a number of resources which I was able to then use to build an understanding to the level that I have that understanding. But I think the first thing you need if you're going to learn about new domains is curiosity, which enables you to do the research, have the conversations, and establish the dialogue.
Okay, questions are coming in. So let's ask this question from Alexander. It seems to me that you are saying what needs to be done is already being done, but we can do it differently. But what is lacking in the current approaches that requires the SE approach?
I think what I'm saying could best be expressed as we can leverage what's already being done. It's not so much that what's being done is wrong or needs to be changed, but that we can offer things. For instance, sometimes in the process improvement world, you find folks who go along through the process and they improve this step and make this step more efficient. And then they move on and they improve a step down the way, and they never step back and take a systemic look at, okay, I've improved this part, and therefore I've improved the total process. And of course, we as systems engineers know that optimizing the pieces, the elements of a system, does not necessarily optimize the system. So we can bring that systems thinking, we can bring that look, we can bring the ability to model the system and model the environment and use that to take a look at very complex systems that you wouldn't be able to get a view of without being able to take that stance and use those tools.
Okay. Okay. The next question is from Cyrus. In manufacturing 30 years ago, we realized that we needed a cultural change. Have you looked at things like quality is free and out of the crisis as a way to interact with high-level C-suite buy-in?
Yes, and hello, Cyrus. Glad to have you with us. I think that's critically important because what you are talking about is definitely culture change, and you cannot change culture without really beginning with the top. And so what you have to talk about is that systems view, the overview of the environment and the overview of the system in ways that they can understand how the improvement of the system is going to result in the kinds of outcomes that they need in order to fulfill their management responsibilities and leadership responsibilities in the system. So it's definitely a process of cultural change, and that's something that we all need to be very interested in and need to constantly improve our knowledge of.
Okay, and the next question comes from Chuck. Are there systems engineering businesses that are specifically addressing the healthcare industry?
Yes, I think there are. There are small organizations which are targeted to that. We are trying to build our footprint in that particular area. For instance, there are consultants. Kendra, that I've talked about, is a consultant who works in that area. There are academic programs that are developing the skills there, that are doing work in those particular areas. Loyola Marymount and Johns Hopkins are two of those that spring immediately to mind. So there are folks out there who are working in this. The consciousness changing that I think needs to take place in order to provide more of that kind of service is within the traditional systems engineering profession.
Okay, thanks, Zane. That wraps up the final Q&A for today's presentation. If you have any other questions or comments for Zane, don't hesitate to send him an email. He would be happy to hear from you with any inquiries you may have. If you don't have his email address, you may send it to me and I will forward it on to him. Thank you so much for coming today. Our next webinar is Analyzing and Specifying Interfaces with MBSE, given by Fran McCafferty, and that's going to be on March 22nd. That link is on our that registration link is on our website. Remember that at the conclusion of this webinar, a survey will open on your screen. Please take a moment to give us feedback on today's presentation or on what topics you'd like to see covered in future webinars. That's all for today. Once again, thank you for joining us and have a wonderful day.
Thanks, everybody.